We are talking about dilations, and we want to draw dilations in the coordinate plane. We want to do a quick review of what we've talked about in the previous few sections. So we've talked about transformations. I guess we've talked about reflections first, transformations, and rotations. Now, all three of these are what is called in isometry. So these are all isometries. And what isometries mean is they have the same size and the same shape. Now, when we say same shape, we're talking about the shape. What we mean are angles are congruent. And when we say same size, we say distances are equal. So that was a review of what we've talked about previously. We've had reflections, transformations, rotations. Those are all isometries. And what that means is no matter how we move it, the shape doesn't change. The distances will remain equal and the angles will remain congruent. So nothing's going to change there. Now we look at dilation. And a dilation is a similarity transformation, not an isometry, unless the k value is 1 or the scale factor is 1. So it's a transformation that enlarges or reduces a figure proportionally with respect to the center point, usually the origin, and a scale factor of k. The resulting image is the same shape, but not the same size. And remember, when we talked about size, that meant the distances change by a scale factor of k. So not the same size. That size portion is talking about the distances. So the distances change by a scale factor of k. Now, same shape, that still means that angles are congruent. So reflection, transformation, rotation, all the distances will be congruent, all the angles will be congruent. When we talk about a dilation, the angles will remain congruent, but the distances will change. So here we have examples of an enlargement and an example of a reduction. So in enlargement, Here we have the pre-image, and here we have the image. So the image is larger than the pre-image because it got larger or bigger. A reduction, here we have the pre-image, and here we have the image. So the image is smaller than the pre-image. So we have a scale factor K is a ratio of the image length to the pre-image length. So that's important to remember. We want to make sure that we put the image in the numerator. So scale factor is represented by the variable K, and that is equal to the image divided by the pre-image. And that's important because that's going to dictate for us consistency. Okay, here is the dilation rule. So if you have a capital D for dilation of K, and you want to do that to all the X and Y coordinates, all you do is you take the K value and multiply it by the X, or the K value and multiply by the Y. Where K is a scale factor, if K is greater than 1, then the figure is enlarged. If K is less than 1, then the figure is reduced. So over here, it says dilate triangle ABC by a scale factor of 2. Or here we have dilate triangle ABC by a scale factor of K is equal to 2. So the way that I like to dilate an image is I just draw straight lines from the origin. And this is going to help and this will help us see where the point has to go, where the new point has to go. Okay. All right, so I'm going to draw a line that goes through the origin and through the point. And I'm going to do the same thing here. And thing for C. So our pre-image, we have A, we have B, and we have C. Now, when we have a scale factor of K, that means everything gets doubled. And this should be ABC there. There should be a C value. So triangle ABC. So we can use this almost like slope. So if we went from the origin, how would we get to point A? So we'd go up 1, 2, 3, 4, and to the left 1. but the scale factor says we should double everything. So now we're going to go, instead of going up 4, we're going to go up 8. So that's 4, 5, 6, 7, 8. And then we're going to go to the left 2, 1, 2. So point A is right there. That's going to be A prime. And A prime should land on that line that we drew if we drew it well. Mine's off a little bit, but it should be there. Next one we have is B. So we're going to go over 2, down 3. And then we can go over 2 and down 3 more. So that's almost like we're doing the slope formula. B prime. And then for C, we went over 3, down 3, over 3, down 3, and there we have C prime. So that's the way you can do it if you want to draw it out, draw some extra lines, and count. That's one way that we can do it right there. Now this is an enlargement, and then we can see that the red image is quite a bit larger than actually twice as large as the blue pre-image. And we can check that just to make sure. So, and we can do that for this one because BC right here is a straight line, so we can just count 1, 2, 3, 4, 5. So BC has a length of 5. Now B prime C prime has a length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it was an enlargement by 2, so it used to be 5 multiplied by 2, and now the distance is 10. So that's one way that you can check if you have either completely vertical or completely horizontal lines. You can check that way. So we could also use the coordinate rule, which we talked about over here, where we just simply multiply. So we have the points of A is -1, 4. And then we had B is -2, -3. And then we had C as 3, -3. So we can use our rule, and our rule just says multiply by 2. So take -1 and multiply it by 2. And then take 4 and multiply it by 2. And what that's going to give us is that's going to give us A prime. So -1 times 2 is -2, and 4 times 2 is 8. Then we can do the same thing for B. So we're going to have -2, and we're going to multiply that by 2. And then we have -3, and we're going to multiply that by 2. And then that's going to give us B prime, which is -4, -6. Then we have our last point here of C, where we take the X value and we multiply it by 2. And we take the Y value and we multiply it by 2. And that will give us C prime. 3 times 2 is 6. And -3 times 2 is -6. So if we check, this should be the coordinates of our image. So -2, 1, 2, up 8, 1, 2, 3, 4, 5, 6, 7, 8. -4, -6. 1, 2, what? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And 6, -6. 6. 1, 2, 3, 4, 5, 6. -6. So there are two ways that you can do dilations. You can either draw it with lines that go through the vertices of your image, of your pre-image. So lines that go through the vertices of your pre-image, and then your image, also the vertices should be on those lines as well. The other way you can do it is you can write the coordinate and you can scale it, both the X and the Y, by the same scale factor.